Hey everyone, I hope you guys are doing well and I hope you are being good for Mrs. Fossen. There's a few things I wanted to discuss about the periodic table of elements. We discussed several things, but I want to add to that and kind of revisit a few things now that you guys are on the chapter over the periodic table. I am going to use my periodic table, obviously, and I am going to use several colors of highlighters. So if you have highlighters, you're more than welcome to take a second and maybe Mrs. Fossen can pause the video and you can grab them. You also should have a blank periodic table of elements in front of you. Since we've already kind of colored on the other one, I wanted to basically start over. Okay, so several things. The first thing is I wanted to revisit where the metals, the nonmetals, and the metalloids are. Okay, so in yellow, I am going to highlight the 6 metalloids on the periodic table of elements. And depending on where you read or what author from your textbook or internet, they might include polonium and astatine. I always like to stick with these 6 because your textbook does. So I like to keep it consistent. So these 6 elements, so I'm going to make myself a key up here like we've done once before. These guys are our metalloids, and we'll talk about some of their properties in just a little bit. If you guys remember, our nonmetals, I'm going to do these guys in orange. Our nonmetals are going to fit all the way over here. And I'm not going to do anything with these guys down here. These are all man-made. So we're going to stop right here. And these guys are going to be our metals. Again, this is a quick reminder. We've done this part before. And hydrogen is also a nonmetal. Okay. The reason why hydrogen is placed where it's placed is because that only has 1 valence electron. So these guys in orange, these guys are our nonmetals. And hydrogen, this guy is over here. So we'll say misplaced. Because 1 valence electron. So he's over there with our metals, our group 1 metals, because he has 1 valence electron. Another quick reminder, all of the elements in a column, these guys are called, our columns are called groups, and then our rows are called periods. Okay. The last thing I'd like to do is highlight our metals once again. And I am going to start here and I'm going to highlight them in pink. We are going to go all the way over here. Again, we've done this before. This is just a quick reminder. These guys in pink down here. Let's see, I have enough room up here. So in pink, I have highlighted my metals. Okay, another quick reminder, the elements in group 1 and 2, 13 through 18 are our main group elements. So I'm going to say groups 1 through 2 and 13 through 18. These guys are called main group elements. And like I said, we've discussed those ones before. Okay, so what we haven't discussed before are the elements in group 3 through group 12. So elements in group 3 through 12 are called transition metals. These guys down here, these guys are actually transition metals as well. See where I have a single star here and a double star here. Notice that this is 58 and this is 90. This guy belongs right up here between 56 and 57, or sorry, let's try that again. right here between 57 and 72. And then this 90, this row or period, belongs right here between 89 and 104. So these two down here actually are called transition metals. So these guys are transition metals as well. Okay. Again, our rows are called periods and our columns are called groups. So we have 7 periods, 1, 2, 3, 4, 5, 6, and 7. And since these guys down here belong between, right up here, between 57 and 72, 89 and 104, these guys are actually in period 6 and period 7 as well. They should be squeezed right in between here. I'm going to cross that guy out since he shouldn't be there. Okay, so these guys down here have a very special name since our element lanthanum actually begins this period. 58 through 71, these guys are called lanthanides. So Lanthanides, lanthanides. So 58 through 71 are lanthanides. 90 through 103, if you can see here, actinum actually begins this period. So 90 through 103, these are called my actinides. Okay, so these guys are actinides and lanthanides. So lanthanides are 58. Actually, if I was to be very, very correct, and let's be very correct, our lanthanides are 57 through 71, and our actinides are 89 through 103. So these guys have each have special names. We got some more special names to talk about. So excluding hydrogen, so the elements lithium through francium, I'm going to put it up here, are called my alkali metals. These guys are the most reactive metals on the periodic table. They are the most reactive because they all have one valence electron. As you go from top to bottom, the elements get progressively more reactive. So what happens is their one valence electron gets further and further away from the nucleus. So the nucleus doesn't have a very tight hold on that valence electron. And so it's very easy for a nonmetal to take it, and it makes them very, very reactive. Okay. These alkali metals are also super reactive with water. So if you plop any one of these metals into a bowl of water, you're going to get a pretty violent reaction. These guys in group 2, these guys are called my alkaline earth metals. So I'm going to find some room over here. I'll put group 1. These guys are group 2. So all of the elements in group 2 are called alkaline earth metals. These guys are great in regard to scratch that. These guys are alkaline earth metals. I was about to say something, but I lost it in my brain. So no, these guys are alkaline earth metals. So groups 3 through 12, again, these guys are the transition metals. These guys down here don't really have a special name for them. Sometimes they'll call them, your textbook I think calls them the boron group. Group 14, straight down here, your book calls them the carbon group, which seems fitting. These guys right here, group 15, are called the nitrogen group, the oxygen group. Group 17 does have a very special name for them. These guys are called the halogens. These guys are called salt formers. So when they combine with metals, they like to form salts. So like sodium chloride, potassium fluoride. So any of these elements in group 17 that form compounds with the metals form salts. And I know we've discussed this before, but all of the elements in group 18, these guys are called the noble gases. And their nobility because they already have a full outer energy level. Helium has 2 in energy level 1, so he's stable. Neon all the way down through radon, again, have 8 valence electrons in their last energy level, so they are stable as well. So what I want to talk about some more are some of the properties of our metals, our nonmetals, and our metalloids. I hope you guys don't have any questions. I'm buzzing along kind of quickly. Let me see. Okay, so let's talk about some properties of our metals. So just metals in general. Metals are shiny. They are hard. They are malleable. Again, malleable means that you can hit them with a hammer and make them into sheets without them breaking into a bunch of little pieces. I like to think of malleable as flexible. Metals are ductile. This means they can be made into thin wires. They're also, of course, you guys know this, they're good conductors of heat and electricity. They have high melting points. They are all solids at room temperature, except one metal, which is mercury, Hg. So this guy is mercury. Mercury is a liquid at room temperature. All the rest of them are solids at room temperature. Let's move to our nonmetals. So our nonmetals, remember, metals are to the left of the periodic table. Nonmetals are to the right, except for hydrogen. Hydrogen's misplaced. And that, again, is because it has 1 valence electron. So nonmetals are brittle. They have low melting points. They are good insulators. They can be good conductors. They're actually, well, no, never mind. Not nonmetals. I was thinking metalloids. Brittle, low melting points, good insulators. They're states of matter. They could be solids, they can be liquids, and they can be gases. Most of them are gases. All of the noble gases are gases, but there are a handful. So if you look on your periodic table of elements, it gives you a key up here: solid, liquid, and gas. So when it comes to your nonmetals, looking over here, you've got, of course, your noble gases are all gases. Your halogens, you have a mix of everything. So you've got some gases, you've got a liquid, and you've got a solid right here. And there's the symbol that tells you right here. Group 16, you've got oxygen as a gas, sulfur is a solid, selenium is a solid. So you kind of have a mix of solids, liquids, and gases. When it comes to your nonmetals, the only liquid at room temperature is bromine. All of the other nonmetals are going to be solids or gases. Bromine is the only liquid at room temperature. Okay, so some properties of metalloids. Remember that we highlighted 6 metalloids on our periodic table: boron, silicon, germanium, arsenic, antimony, and tellurium. Those are our 6 metalloids. They're sandwiched in between the metals and the non-metals, so they have properties of both of them since they're right in between them. These guys are all solids at room temperature. They're shiny, like metals. They are brittle, like non-metals. They are called, sometimes they are called semiconductors. And these guys are good conductors at high temperatures. Okay, those are physical properties of metals and non-metals. And metalloids, excuse me. If we were talking about chemical properties, some chemical properties would be that metals like to lose their valence electrons, non-metals like to gain valence electrons. Metalloids quite often like to share their valence electrons. Those would be some chemical properties. I want to look at one more thing with your periodic table. So grab your periodic table. And I just want you guys to be able to identify some elements. So for instance, if I was to say, let me give you the question first. So if I was to say, what element is found in group 15, period 3. So if I said, I need you to identify what element is found in group 15, period 3, I'm going to come over here, and the rows are our periods, the columns are our groups. So group 15, period 3. So remember, this is the first period, this is the second period, this is our third period. So third period and group 15, I come all the way over here to group 15, and my element would be phosphorus. If I said to you, what element is found in group 1 and period 4, I would come over here, group 1, period 1, 2, 3, 4, that would be potassium. If I said to you, what element is found in group 17, period 4, I would come over here to group 17. This is period 2, 3, and 4, and that's going to be bromine. So you will have several questions in regard to that, so I just wanted to clarify that. Hopefully I will go ahead and, not hopefully, but I'll go ahead and post this periodic table on Google Classroom. That way, if I went too fast, you are able to access it and make any changes. Okay, you guys, hope all is well. Hope you guys are being good. I miss you guys. And I hope you have a wonderful day. Take care. Bye.